Hey guys, hi and welcome to the video. My name is Saumil Shah. I work as a software engineer. In this video, I would like to teach you about essentials about PySpark, basics about PySpark. If you are a complete beginner, this is the video for you. Well, data has been growing massively, right? That's why the big data is emerging. So that's why traditional pandas doesn't work, and that's why we need to learn the essential skills such as PySpark, Scala, Impala. Then we have cloud platforms such as Cloudera and then Databricks and all that stuff. But in order to even learn that, let's get started with the very basics first. So this session will essentially focus on PySpark. So let's learn PySpark, and then we'll slowly we go to Scala and other stuff like that. Okay, so let's get started. Usually people have problems running PySpark, right? So I usually, prefer Jupyter Notebook because Jupyter is an OS independent. It does not matter whether you're using a Mac or a Windows or Ubuntu. So it's gonna work, right? So essentially, I'm saying that Docker run -it -rm, exposing the port and providing a volume, and then I'm just providing my image. By the way, the entire notebook, in this video, as I said, I'll be covering about all the basic syntax of PySpark. We'll be going over filter commands, aggregation, group by. I'll have so many examples that would clear your concepts. We'll also learn about UDF, user-defined functions, filtering out a particular rows, column, iterating over it, partitions, and much more, man. So as I said, very basic. All the references where I have learned all these materials is also there. So let's get started and let's learn about PySpark, man. I'm excited. Let's get started. So follow with me. Stop the video where you require to and try this out by yourself. Okay. So first thing foremost, that what I need to do is, and I'll try to zoom as much as I can so you guys do not have any problem in seeing it. I'm saying from PySpark SQL import Spark session. So essentially, I'm importing the Spark session here. The first thing what we need to do is we need to create a Spark session. So we are saying Spark session.builder. We are providing the app name, master, get, or create. This would essentially create a Spark session for us. And now we are good to go for any data manipulation and stuff like that. If you see this message, hey guys, congratulations, you just got, everything is installed correctly with PySpark. So if you get this message, good to go, okay? Now let's take a, so I don't want to take much complicated examples like other people, and massive data. Let's learn with a very basic example. That's how I learn, right? I take very basic steps and then I learn stuff. So this is how the data looks like. Let me just do a list and I show you. So essentially I have a list of tuples, which with essentially you have, this is string, this, right? So essentially I would like to create a PySpark data frame. So we need to provide a schema, right? For example, we need to say, hey, this is a string, this is that. So this code right here would do that. So we are saying that struct type, that means you're saying that, hey, this data frame would have following columns. We have 3 columns. This is one column, struct field. We're saying we have a field called city. It's a string type, and there can be null values, right? We are providing a schema for that, or metadata database. Once you do that, then what you could do is essentially you could say df is equal to spark dot create data frame. You provide the data, list of tuples, and schema. Remember, if you're reading from a file or directly from S3 or stuff, you don't need to do that. I'll have some separate tutorials for that. But for now, as I said, very basic. Okay, let's not complicate things. Okay, so we run the cell. Now what we could do is you can say df.show. This will basically show you the data frame object. And if you see this a null object sometimes, that means that the Jupyter or the cells were not run correctly. So you know what I would do essentially in this situation? I would just rerun the cells again. So as you can see, I had this problem, right? So now I'm just gonna fix that. So let's run this. And there you can see now we have that result. Now let's learn about these basic commands and let's just understand things a little better. So the first command we have is df.collect. Essentially retrieves data from a Spark or an RDD data frame object. So you can say df.collect and it will return you the data, right? If you say df, this is essentially a data frame object. Remember, this is a data frame. That means it's just like a pandas data frame on which you can manipulate that. But if you use .rdd, now it's an RDD, so it's a distributed, so I'll cover about RDD a little bit, but these two things are different, right? Data frame and RDD are different. But yeah, you could also run, I think you can run commands on RDD as well. But yeah, just wanted to, bring this to your attention right now. But as I said, let's not complicate things up, okay? So we saw the collect command, right? Then the second command that I would like to introduce you is df.take. Take essentially returns you the first n rows in a data frame object. So that does that. Similarly, the head does the same thing. You also have a head. You can say df.head returns the first n rows in a data frame object. If you want to get the first n columns, so you could say tail. Tail would return you the last items from the data frame object. Now let's learn how to select columns, manipulate columns and stuff. So if I want to select a column city, how would I do that? Well, the way you would do that in PySpark is PySpark has a command called df.select. You provide the column name, right? And then you say .show because you want to see the data frame. So this would essentially select the city column and it would show you. Saumil, how do I select multiple columns? I want to select city and type. Well, it's pretty easy. You provide an array of selection. So here, as you can see, I'm saying, hey, can you please select city and type and then show it to me? Let's run that. And here you can see. So, so far so easy, right? Now let's learn about filter commands, right? How do I filter? So let's say I want to say that, hey, I would like to get data where the city name is Paris. How do I do that? So you can use df.filter, and then inside that you have to provide the column on which you want to do a filter. So I'm saying that, hey, do the filter on a column city where the value is equal to Paris, and then show me the data frame. So let's see. So now you can see you only got Paris. Saumil, how do I add multiple argument? For example, if I want to do an AND operation, an OR operation, how do you do that? Well, I'll show you. I have a lot of examples, as I said, would clear all your concepts. So this example here, it says df.filter, filter the data frame where the city is equal to Paris. Then again, after that, filter the data frame where the type is equal to food. So as you can see now here, we are doing multiple filter commands and it works fine. But Saumil, isn't there an AND command there? Well, you can use that as well, but I just wanted to show you all the possibilities. If you do not like this, if you do not like doing multiple filters, you can run an AND here. So here you're saying df.filter, hey, filter out the data frame where the city is equal to Paris and the type is equal to food. So one important thing, if you observe, the arguments has to be inside a tuple, okay? If you do not follow that, you will have errors. So please note about the syntax, okay? So you run the command, would show you right there. So that's that. Now, a couple of more just to, so that your concepts, you understand this so well, right? So I have, again, a lot of, so here I'm saying, hey, filter out the data frame where the city is equal to Paris and the price is greater than $18 and only give me the city, right? So when I run this, it would give me the city that it would give me a data frame where the city is Paris and the price is greater than $18 or 18 whatever number. So I'm just making sure that you get up to the pace here. So now a couple of more example, right? So filter. So this example says, hey, df.filter where the price is less than 20, order by. So you want to order essentially, make sure that the data frame is ordered properly, and you want to order by price, and you want to do it as ascending, and then I'm just selecting the price column. So if you run this, you'll have this one. So it's an ascending 8, 10, 12, 15. So we said we filter out all the data where the price is less than 20. We ordered the data frame in an ascending order, and then we are selecting the column price. So now you can see how we are using all these things that we learned in the first part, right? One more example I have for you guys. So try to read this example and see if you can if this makes sense. We are saying that, hey, filter out the data frame where the price is less than 20, sort the data frame by ascending and select the price. This is essentially the same thing, I guess I showed you, but you can also run descending, ascending, whatever you want, but you got the idea, right? So now I would like to show you about manipulating columns. That's important for us to understand and learn. So let me essentially print the data frame. Okay, so this is our data frame. All right. So the first thing that I would like to show you or teach you is basically how to add a new column on PySpark, right? So for example, this one would show you that. So this example here, let me zoom in a little bit. So we're saying with columns. With columns is the keyword used to add a new column. I'm saying, hey, add a new column called 50%, and I'm providing what I want to do. So for example, I'm saying take the price column, divide by 2, and add it in this new column. So let's see how it looks like. So we got this new column with the appropriate price here, right? So essentially you can add a new column as well. Excuse me. So you can add a new column with this approach as well. All right, so that's that. Now let's move forward in the tutorial series. Now the next command is the drop. If you want to drop a particular row, you have the ability to do that. So use the command drop, and then you say which column you want to drop. So you can say, hey, I want to drop type, man. So if I run this, hopefully the type is gone, and sure enough it is, right? Now, if you want to do a couple of more things, I just want to show you some commands here. So this command right here, we are saying, hey, let me essentially, so if you want to drop essentially multiple stuff, you're saying that, hey, you know, drop city and then price, and then filter out the data where the type is food. So we are doing multiple things. We are dropping and then we are filtering out. So if I run this command, let's see how it looks like. This is how it looks like, right? So essentially we're just practicing all these commands. If you want to rename a column, you have the ability to do that. So for example, with column rename is one of the methods you can apply on the data frame object. And then you provide the original column and the new column name. So if you do that, as you can see, the column is renamed now. Okay. So that's how you would rename a column. Let's learn about user-defined functions, man. This is very important. So let's say, as you know, this price one, let's see what's the data type of this. So this price is essentially a float, but if you want to convert that into a string, you have the ability to do that. So user-defined functions allows you to do that, right? So let's call this to, so this function, I think it's string. Yeah, it's string. So this function essentially would convert this data type object into a string. That's exactly what we want to do, right? So now, you know, let's learn how to do that, right? So give me 1 sec while I do that. Okay, so the way this works is, I'm just gonna, so first of all, you need to select. Now, in this select, you have to select a column that you wanna apply transformation on, right? So I'm saying that, hey, I would like to apply a function to string, and I would pass in the price to it, and alias is basically, I'm just, you know, I wanna, when the data frame is created, I want a column to be renamed as price. So if I just run this, and I just wanna show you how it looks like. So essentially it returns that, right? So, but this now is converted back into a string. So essentially what you just learned is how to apply a UDF, a user-defined function, to a data frame object. So you can use the word select. So you have to select a particular, column. I said, hey, I would like to select price, and then I applied this function to that, and then I just did show. Now let's look at some complicated examples, which might be a little bit useful, right? So again, we'll go back to df.show. You have this right here. Now what I want to show you is now something like this. So for example, if I want to convert this column into a JSON, so for example, this price column, I want to convert this into a JSON. So for example, if the price is less than 8, I want to return this JSON, else I want to return this JSON. So I would like to change it, right? So I want to apply this function now. So you wrote the function. Now what you need to do is you need to essentially say UDF, right? And I would try my best as much as I can to explain you this. Okay, so here I'm saying that UDF, I'm essentially registering a function here. So my function is essentially to some transformation. This is a function name, right? And then I'm saying you have to define the return data type. This function is returning a dictionary, right? It's in PySpark language, we call it a map object. So we are saying a map, so the key would be a string and the value is also string. You have to define a data type, right? You have to tell that, hey, what data type you're expecting, what's going to return and stuff like that. So if you run this, right? Once you run this, then you need to apply that. So I'm saying df.with column. So I want to add a new column called new. And essentially I'm applying that the function that I just registered, and I'm passing the price variable to it. Let's just see how it looks like. And and of course, as you can see, but we'll review this again because I know it's a little hard to get to understand at first. First of all, you define a function, right? And whatever data type it's returning, then you need to define, or you need to first of all register the function. So the word UDF registers the function. Then you supply the name of the function that you want to register and the return data types that the function will return. In this case, it's returning a map object or a struct field, whatever it's returning, you define the data type object. Once you have registered the function, then you essentially use the word with column. If you want to create a new column, or if you want to add to an existing column, you can simply select the existing column and you can do that. So here I'm saying that UDF category. So when you register the function, now I'm essentially passing the column that I want to apply the transformation, and then I'm just calling .show. So now my columns are converted into a nice beautiful dictionary, right? So that's that. Now if you want to remove null values in a data frame object, now let me show you how to do that. Of course, you have something called as df.dropNA, but as you can see, these are empty string. These are not NA objects. So if you try to run this command, PySpark has df.na.drop and then show. But if you run this, you still see that there are none values. How do I get rid of that? Well, the only way you can get rid of that is writing a custom UDF or a user-defined function. So this function which says if it's an empty string, return 1, else return 0. So returns a true or false essentially, right? Now similarly, we have to do the same thing. We need to register a function and we need to tell what data type that the function is going to return. So I'm saying that this function is going to return you it's going to return you an integer. Then I said df.with column categories. Then I'm essentially passing the first name column to that, right? So now if you see this, this is how it looks like, right? Now you want to filter out, right? You said you want to filter out, right? So now you will run the filter command, man, and this is how you would do it. So you'll say, give me the data frame where the category is 0. So essentially 0 is where the name is not null, right? So you just filter out the data where the name is. So essentially if your normal drop.na does not work, then you could run a custom UDF and then you could do it this way. Again, just reviewing the steps, you define a function and what data type it returns. You register a function, you apply that function, and then you filter out the value based on the flags. Simple, easy, and easy. That's not complicated, right? Okay. Now I would like to teach you one thing. I would like to show you is essentially about partitions. And if you want to learn more, as I said, you can read these references that I have here. They would explain you in much detail. So partitions, essentially, whenever you create a Spark data frame object, there are several workers, right? So every small, so internally PySpark divides the data frame into several small partitions, and then basically they send this partition over a thread or something over a network, right? So they transmit that data. The worker would execute and then return the data back, and it would combine or do aggregation of that. So let me just read a couple of definitions here. This might be useful, trust me. Spark splits the data in order to process it in parallel in memory. Once the user has submitted the job, the cluster, each partition is sent to a specific executor for further processing. Only one partition is processed by one executor at a time. So the size and the number of partitions transferred to the executor are directly proportional to the time it takes to complete them. Thus, more partitions, the more work is distributed to the executor. With a smaller number of partitions, the work will be done in larger piece and often faster. Very important, okay? The most important reason is the performance. By having all the data needed to calculate on a single node will reduce the overhead on shuffle, the need for serialization and network traffic, because he has to send the data to the workers and then or has to serialize, he has to deserialize. The second reason is the cost reduction. Better utilization of the cluster will help you to reduce the resources. So this I have taken from the reference too. You can go to the link and read more. Well, so there is two things that I would like to cover here. First we have partitions, and then second we have coalesces. Now you'll say, what the hell is this, right? Well, partition specifies the number of partitions up or down. Coalesces uses the existing partitions, only decrease, no shuffle. Okay, hang on, I'll explain you. Don't go crazy. It's actually very easy. So I'll actually like to show you with a small example if you don't mind. So I'm gonna switch here, right? And I'm actually gonna run some code. So essentially I'm converting my data frame into an RDD and I'm saving it as a text file, right? And I wanna show you something, okay? So just hang on, bear with me for a while. Let me just complete this. Okay, so before even I run that, I would just wanna say, so this is my data frame, right? We have this. So essentially, I'm gonna run all the three now, and it should essentially save the data in the file. So now what this does is basically, if you see df.save as text file. So now if the number of partitions are 8, so what I'm trying to say, by default, Spark would have the data in chunks, right? It would be in partitions. So for example, in order to know how many partitions you have, you could run the following commands. I think it should work. So we have 8 partitions. That means the data is stored in 8 blocks, or so as you can see, partition 1 is empty, partition 2, then we have partition 3 where my data is belong, 4, 5 is empty, we have partition 6, 7, so you got the idea, right? So that these are partitions. So now when I save it, when I normally save it, see what happens, okay? So remember the folder name was foo, right? So test1, this is how you save it normally. So as you can see, data is stored in individual partition, right? So it's divided into, so this partition is empty, right? So let's look at the partition 2. We have data in partition 2. So you got the idea, right? So number of partition essentially is important when you save a file, or it makes a difference, right? But in this case, when you use, so you can always repartition it. That means when you do repartition, so for example, this line right here where I said repartition 2, so you should just have 2 files here. So if I go to the same folder, projects, foo, test2, I just have 2 of them. So each should have like 1 or 2 data points. So exactly 1 or 2, because you just have like 2 or 3 rows, right? So you got the idea, right? So basically the repartition allows you to change the number of partitions. Coalesces only allows you to decrease the number of partition. It does not allow you to go above. So essentially, now if you look at the third example, test3, so all the data is in one file. So this is what coalesces does. Coalesces would essentially, you see, so you got the idea, right? What I'm trying to say. This is extremely important. As I said, if you want to dig more deep into that, I have the references here on the bottom section. Please go for it and read more if you want to dig a little more deeper into that. But on a high level, this is what partitions are, man. So don't want to confuse much on this, but yeah, this is what partition does. Well, how do you iterate over a particular rows or columns? So I just want to talk about that as well. Like in pandas, you have iter rows, right? So in PySpark, you can say df.rdd.collect, and then you can, if you want the city, wait, something went wrong, and oh, we don't have that. So essentially, so you could do that way, or if you remove that, you'll have this. But this is essentially how you iterate over an object. I just wanted to show you guys in case Then you have a group by, for that I need to rerun my original cell, because give me a second, guys. Okay, let's go down. So if we do a show, now we have that, right? So now I would like to show you the group by command. So we are saying that, hey, group by city, and they take a mean of the price, right? So it would do the computation for you. Remember, now there are 8 partitions. Now, as you know, more partition, the data frame is divided and submitted to all the executor. The more time it takes, lesser partition, larger work is done on the cluster, but faster it is. So it really depends. You have to really play with the partition number and see what's the appropriate, but whatever. So this is how you can perform group by, right? Now, if you want to get the list of unique columns, well, there's a word called distinct. So if you want to get distinct city, the city name, so if you run this one, it would essentially give you the distinct city, right? So this is that. So that's that, and then I want to cover about aggregation. So aggregation is essential if you want to see, okay, how many, if you want to just do an aggregation, for example, let me just run the df.show. So let's say I want to see Paris 1, 2, 3. So there are 3 Paris, right? I just want to do an aggregation. So PySpark allows you to do that as well. So the command is group by. You provide the one on which you want to do aggregation, on the column on which. Then you use the word ag. Then you say you want to do on everything, and you want to do a count. And then you want to order by city and ascending as false. So if you run this command, essentially it would give you an aggregation of the cities, right? So let's see. So Paris, there are 3 with Paris, Leon, one is there, whatever. But that's that. But these are, as I said, this is everything that you need to know for a beginner for PySpark. We took a look at the basics of PySpark, about various filter commands, aggregation, group by, how to select a column, how to filter an item. These are the references. The entire notebook here is also there on my blog, and the links are in the description as well. But with that being said, I hope this was useful and you really enjoyed this small walkthrough or tutorial series on PySpark. Once we have the fundamentals, now we could learn more and more complex things, right? So now we'll slowly learn into, okay, how can we use this PySpark on maybe AWS, right? How can we write a glue job, or stuff like that. So we'll learn about now linking. So understanding the basics is important. Then slowly we'll also jump into Scala, right? How can we learn about Scala, right? So with that's it for this video. I just want to say thank you so much for watching, and I hope you have enjoyed this PySpark crash course. And if you did really enjoy this PySpark crash course, let me know in the comment section below what you think on that, so I can create more valuable contents for you. With that being said, thank you so much for watching. Keep smiling, keep coding, never give up, and I would see you in the upcoming next video. And by the way, if you have any questions, list them in the comments and we'll get back to you as and when as I get time. Thank you so much for watching. Goodbye, everyone.